Okay, our last question, everybody. Question number 10. An electron and a proton of mass given here are accelerated from rest by the same potential difference. So the de Broglie wavelength, okay, I've googled how to pronounce it. It's not de Broglie as how I pronounced it before. It's actually de Broglie wavelength for the electron and proton are shown here as well. So find the ratio of this in terms of the masses of electron and proton. Okay, so we know that the de Broglie wavelength is equal to h over the momentum, where the momentum is equal to mv. So we can write this down as h equal to mb. Okay, so if the kinetic energy of an electron is equal to half mv square, so we know that both of the proton and electron would have the same kinetic energy. Okay, so we can just write it as k lah. Okay, so they will have the same kinetic energy, and then from here we can then let v to be equal to square root of 2k over m. Yes, okay. So from here we can then substitute this into v over here, so we get h over m 2k over m. Okay, betul kan nih? Kejap. Yes. So we can then write it as lambda equal to h over square root of 2km. That is the 2mk. That is the simplified one. And remember, the kinetic energy gained by each of the particle is the same. Okay, so if we were to do the ratio, we have h to mass of the electron, kinetic energy, to mass of the proton, kinetic energy. So we can then actually cancel this lah. Okay, so you are then left with 1 over square root me over 1 over the square root of mp. Okay, so rearrange it again, you will get mp over me square root. Okay, all right, I hope you are able to understand this part of the question. Okay, yeah, so that is the end of our chapter number 10.